Hey everybody, Kite here with Kite Talks About, and here are the DS18B20, which is a waterproof temperature sensor that can detect the temperature over the air as well as when it's submerged in water. So for this experiment, we're going to need 3 DS18 Bravos, which we'll have connected to the one-wire protocol, and we'll also have 3 male-to-male jumpers, one which is your green, which is ground, your yellow, which will be the signal wire, and your red, which will be your 5 volts. We'll also need a breadboard in this case, a 10 kilo ohm pull-up resistor, as well as the Elegoo Nano microcontroller. However, you don't have to use the Elegoo. You can use the official Arduino, or you can use an Atmega rig if you so choose. So the first thing you want to do is to go ahead and get the male jumpers and go ahead and connect the green to your ground and the red jumper to your 5 volts, and the signal for this example we'll just have it go into digital pin 2. However, you can connect it to any of the digital pins, to be honest. So now your red 5 volt wire will go into the positive rail of the breadboard, and you're going to have your ground go into the negative of your breadboard. Then you're going to have a 10 kilo ohm resistor between the pin that you're going to use and positive. Okay, and you're also going to connect this yellow signal wire right next to that. So the first thing we need to do after unfurling these wires is to get the address, the hexadecimal address for all 3 of these DS18 Bravo 20s. So I'll show you the general hookup first. So of course you want your ground to go to ground, your 5 volts, which is your red wire, you want that to go into the 5 volts of the breadboard, and you want your signal wire to go between the signal wire leading to your Elegoo microcontroller and the resistor. So have it like that. So the first thing we're going to do, we're going to hook each one of these DS18 Bravos. We're going to hook them up one by one, and we're going to run a program so that we can get the hexadecimal address for each of these devices. So I'm going to connect this, connect it to the computer. I'll get the hexadecimal address. I'll unplug this one, and I'll go to the second one, do the same thing, unplug it, go to the third one, then unplug it. So after we do that and get all the codes and get them recorded, then we'll come back here and we'll have all of them connected off of the one wire protocol now that we have all of their addresses. So let's go ahead into the computer. Okay guys, so we are in the Arduino IDE and we have 2 windows opened up. The first window is our 18 Bravo address finder, and that's where we find the address for each DS18 Bravo 20. And the second one is the actual program that's going to tell us the temperatures. So I had 3 18 Bravos. However, one of them was actually supposed to go into my recycling bin so I could recycle it, the wires and whatnot. However, I forgot to sever it to show myself that, hey, you're not supposed to use it. So we're only going to be working with 2 18 Bravos, not 3. There wasn't a defect. It's just that I made a mistake when I was learning how to use it, and it needed to be recycled. So without further ado, we already have the Elegoo microcontroller connected. Verified the board, the processor, as well as the COM port, and make sure that the program is the ASREFS MK2. So what we're going to do is go ahead and upload this code into the Elegoo, and your COM port is going to be different from mine. So mine is 7. For somebody else, it might be 3, 9, 12, etc. It could be any number depending on the computer that you have. So once this uploads, we're going to open up the serial monitor, and then we're going to record the address, the hexadecimal address. There are some codes when you look online that don't give you the hexadecimal. It's just a bunch of numbers and letters. That doesn't work. It has to be the hexadecimal. So I'll actually include this code in the description of the video so you guys will know what you're supposed to input. Just make sure that you have the one wire protocol already installed as a library, which should be for your Arduino. But beyond that, all you need is to copy and paste the code, and then you'll be good. One thing you need to make note of, though, is right here where it says one wire DS and then has parentheses 2. That is actually the digital pin that you will have your 18 Bravo connected to. And it could be any digital pin. It doesn't have to be 2. It can be between 2 and 13, to be honest. So just make sure that you guys know that, as well as here it has defined one wire bus as 2. You can change that number to any of the digital pins, just so you guys can know. So we're currently uploading and we are done. So let's go ahead and open it up. And here's the address for one of them. So we're going to move this to the side and we're going to highlight this, Control C to copy it, and Control V here. All right, so we have the address for the first one. We're going to go ahead and disconnect it, and we're going to get the second 18 Bravo, and we're going to connect it the same way we did the first one. So you always want to connect your ground first, and then your VCC, and then I do my data. Okay, and now we have a second one connected. So we're just going to open it up again, and we're going to get a different address. All right, so you can compare it. The last one is 18. This last one is 15. So I'm sorry, it's not 15. It's 18 for this one. It's 50 for the one before. So that's how you know it's actually a unique address. So we're just going to go ahead and copy this if we can get the 0 included. Okay, V. All right, so now we don't need this anymore. We can go ahead and close this out. And now we're just going to be working with this. So the only thing you need for this code is the address. Everything is already set. So you define the device address for both of them, and it already starts the baud rate at 9600. You don't need this portion. You can put special message. So let's see, we can change it to anything. Like I said, this part isn't mandatory, but let's just change it up. All right, cool. Just put something if you want to. You don't have to. Then it's going to start the sensors. I have this. Actually, first let's go ahead and put in the serial port and upload it. So now as it's uploading, I have it starts the 9600 baud rate on your serial monitor and has the serial print line initiating DS18 Bravo 20 protocol, which you don't have to have. You do have to have this section though. This starts the sensors, the void loop, and then here is your serial print line, and it tells you what the reservoir 1 temperature is as well as a reservoir 2. The rest of this is mainly stylizing it so that it's not all bunched up. And then you have your delay, which is 5 seconds. I have the 5-second delay on purpose because it takes about 5 seconds for you to get a new temperature, an updated temperature, like for it to notice, oh, there was a larger increase in temperature. If you have it on 1 second, you will still get a result. However, the computer, the chip that's inside it, won't have enough time to adjust the temperature either up, down, or keep it static. So that's why I use the 5-second interval. I also have it print lining these characters so that I can know when there's a new reading and an old reading. So the first thing it does is print these asterisks, and then it goes ahead and tells me what the reservoir 1 and reservoir 2 temperature is. Then it prints this at the end, waits 5 seconds, and then it loops back. So I can tell the difference between, oh, this is the bottom, oh, this is a new reading every single time. So now that we are done uploading, we're going to go ahead and connect the second DS18 Bravo. So we don't have the serial monitor open yet, so we're going to connect our ground first, because you always want to connect your ground first. And then your 5 volts. And then once you connect your 5 volts, you want to go ahead and connect your data line to the same data line being connected to the where the first 18 Bravo is connected to. So let's go ahead and open this baby up. Boom, there you go. So I have them labeled as reservoir 1 and 2. Right now this is the over the air temperature. So to verify that it works, we're going to grab one of them and we're going to, I'm putting it between my hands and watch how it adjusts. Let's extend this a little bit. There you go. So if you check the bottom, you can see that reservoir 1 is actually increasing in temperature drastically. And that's because it is sensing the temperature of my hand, my natural body temperature, which is about, I believe it's like 95 to 96 degrees. So this shows you that it actually does work on the one-wire protocol. So we're going to go ahead and put reservoir 1 sensor down, and now we're going to put the reservoir 2 sensor in my hand and watch how its temperature starts increasing while reservoir 1's temperature is quickly decreasing already. So this is just proof of concept. It shows that it works in the code. So now what we're going to do, now we have everything uploaded, we're going to X this out and we're going to go ahead and save this. So here we are. We actually have one of the reservoirs activated and it is heating. So if you listen closely, that's actually it heating up. So this is pretty darn hot and this is not so hot. So to prove it, I'll actually put my hand in the water, and there's no way in the world I'm putting my hand in this water. So we'll, that's how you know it's actually pretty warm, pretty hot actually. So what we're going to do is open up the serial monitor here. And as you can see, let's go ahead and disable the auto scroll for right now. As you can see, the temperature for reservoir 1 is 78 degrees. For both of them actually, is 78.8 degrees. And we're going to enable the auto scroll now. And you can see it's pretty stable at 78.80 degrees. So we're going to get one of the DS18 Bravos. And this is the waterproof version. And here's how you prove it. All right, so we got it in here. And immediately you can see reservoir 1, the temperature for it is increasing. We are currently at 122 degrees and climbing 132 now. All right, and 78.80 degrees for reservoir 2. So we're going to grab the reservoir 2 DS18 Bravo, unfurl it as best we can, and I'm going to go ahead and put it in here. So here it is right here. Okay, so let's move this to the side. All right, so for reservoir 1, we have a steady temperature of about 123.8 degrees. Okay, it is, yeah, we're good at 123.80, and it's slowly increasing. Oh, actually we have it closer to the, there we go, let's bring it close to the surface. Yeah, it looks like we're stable at 123. Oh, we increased. So before, a couple seconds ago, when you look at the water level where it's in, it's now closer to the surface where it's hotter because the heat rises, but before it was like closer to the middle, so the temperature was a lot lower. So right now for reservoir 1, we are at 157 degrees and climbing, and for reservoir 2, we are at 69.8 degrees. And yeah, that's the proof that it's waterproof. So here you go, the hot one, and here's the cold one. Let's check its level. It's closer. It's closer to like it's closer to the top. So we're almost actually at the sterilization temperature for reservoir 1. It needs to get up to about 160 degrees. That is the temperature at which bacteria, fungus starts breaking down. And when you have it sustained for about 30 or so minutes, Legionella bacteria actually can't even reproduce. So we are slowly getting to that temperature. But it's close enough now. It's only like, 0.2 degrees off. So as of right now, I would be okay with starting a timer and waiting the 30 minutes before I was certain that the Legionella bacteria would be dead. However, you don't have to worry about any bacterial or viral infections with this water because it's not from like a creek or a river or anything like that. It's from my tub. So you just turn on the water. So that's why I'm not really worried about anything. However, because this water is going to be sitting here, this water reservoir is going to be sitting here for a long period of time, I know that there's going to be bacteria, fungus growing at an insane rate because it's cool, it's open to the air, and it's dark. So they're definitely going to be reproducing like crazy. So that's why I want to have this. I'm actually going to implement a filter as well I'm actually going to be getting that later this week. I get a filter, and then I'll set everything up so that the cloudiness, you can't really tell here, but it's actually a little cloudy from when I did my hand in this reservoir. I introduced a lot of bacteria that's naturally on my skin, and it reproduced like crazy, and now it's pretty cloudy. So I'll put it through a filter, and that filter should clean it up so that it's a lot clearer, and I can maintain that. If I maintain the cycling, the filtration, like once a week, once every 2 weeks, it heats everything up, sterilizes, and kills everything that's inside of the reservoir. Then it goes through the filter, and then it gets returned here into the reservoir. So right now we are actually at sterilization temperature, which is 160 degrees. 160.7 degrees is where we are currently. So it may climb a little bit more, but it's basically around its max, this heating flange. And I actually did make this myself. The only thing is, as of right now, until I finalize the design, I gotta make sure I don't touch these two terminals where everything's plugged into, because if I do, there's a high likelihood I will die from getting electrocuted. So what I just need to do is get some oven, it's like an oven safe paste that you put over it, and that'll insulate it to ensure that you can, if you wanted to touch it, which you shouldn't, no matter if you have insulation or not, you can touch it and then nothing will happen, you won't die. I don't claim responsibility for anyone who is trying to make the same reservoir like I did, but if you do decide to do it, I'm not responsible for it. You take the risk on your own, and all that jargon, so I can't be held legally responsible if someone made a mistake and killed themselves. I've already proven that this works, so we're going to go ahead and take this reservoir 1 out, and you can already start seeing the temperature drop. It's now at 158, 146, and in the next couple seconds, 140. So this is fairly accurate, I have found. And I connected it just as I told you when I was in the IDE. You just connect the 10 kilo ohm resistor as a pull-up resistor. So you connect it to your 5 volts, which is your positive. That connects to the signal wire, the yellow wire of your DS18 Bravos, which in turn connects to the pin 2 of your LEGU microcontroller, and then you connect your positive to positive, negative to negative, and then you can get the same readout that I have. We're currently falling down to 130 degrees and falling. So yeah, that's everything, guys. So thank you for watching this video. This was the demonstration of the DS18 Bravo 20, how to have multiple 18 Bravos connected on one wire, and how to configure the code, and as well as how to find the device address. So please like, share, subscribe, comment below, share with your friends, and hit the bell icon so you'll be notified of other videos. This is actually what I'm going to use for my these 18 Bravos, or what I'm going to be using to tell the temperature of the water reservoirs for Project Felstinger, the Revamp project. So without further ado, I'll see you guys in the next video, and have a blessed day. Bye.